everybody. Yes, bonjour. Yo muta, gamba muta mwina. So you're with Joseph Wilrich Lutalo at New Tracy ICT Research, and it's a fine afternoon at the start of March 2025. Is the 3rd. It's a Monday. Surely we are starting our Ming, and in this short session that we're going to have together, I wish to bring to your attention some very important updates and terrific milestones that we have struck. Yes, concerning some important milestones that we have attained in the domain of computer science, software engineering, but especially in the subfield of software language engineering. So I'm going to give you the details in a moment. So before you hear, we have several publications. These are all documents relating to the transforming executable alphabet. It is a programming language that I have been working on since 2021. We have written a lot of scientific papers. Many of them, of course, are currently published, and you can access them on the internet. For example, the transforming executable alphabet, A to Z command specification, that has. So the reason why these works are out there is so that people who are going to enjoy using or building solutions on top of this programming language, it is important that they are not just guessing about what the technology is capable of doing, why certain things are done certain ways, because the T standard as it is right now is pretty much stable. Since October 2024, we have not touched the standard up to now, and yet a lot of terrific things have been accomplished already with the T language as it stands right now. We have published a paper on the debugger that is part of the T implementation. It's a very interesting debugger because many other languages normally require you to bring on board an extra tool, an independent tool or tool set to be able to do things like software debugging when building software solutions using those languages. But for the T programming language, the debugger is put directly in the runtime, and so when you install T, you get with it the debugging support tools. Also, we have written a paper on philosophy concerning transforming power in various symbols, letters, and words. Essentially, in would say works of expressing human thought. In 2024, I wrote a paper. It's called a PCM paper because it touched on philosophy, computing, and some bit of mathematics. But it was a one-pager essentially. Probabilistic computing, philosophy of computational mysticism. So why these topics have come up is because many people in computer science, from what I've observed, and even in software engineering, are mostly focusing on the technology, languages, tools, interfaces, etc. But many people forget that computers were created or they were invented to actually support humans, and humans have a lot of other issues about their problems and what needs to be addressed in their life. So philosophy brings on board certain issues, human factors that we as technologists, as inventors, as engineers need to bring into mind when thinking about solutions. So, for example, this recent paper concerning transformative power in various symbols, words and letters, it brings out some very critical matters about how the communication and expression of certain ideas can bring about transformations in society. It can influence the way people think, not just about technology, but about themselves when using this technology. For example, if you find a person who has studied mathematics, let's say up to university level, and you compare that person with someone who has only learned maybe mathematics in kindergarten, who only knows how to count 1 up to 9 or up to 10, or who just knows the names of the numbers but not their properties or what they're capable of. The way the two people look at reality, you could say, might be different just based on the knowledge they have of how mathematics helps to appreciate and define our reality. Not just subjective reality, but also objective reality. So also the same happens with programming languages and computing technologies. People who know the programming language C is one very popular programming language. But you find that someone who has grown up or who has been taught in school how to program in C, when compared to someone who knows only maybe Java or who only knows PHP, these two people will look at technologies and what's possible in a different way. On one end, you have someone whose knowledge or appreciation of technology is so much abstracted from the real machine, the physical machine, and on the other end, you have someone who can appreciate the hierarchy or the spectra of technology, right from the machine level all the way to graphical user interfaces and higher abstraction. So the T language or the transforming executable alphabet. First of all, the language design itself is pretty much unique. People think about the alphabet as a way to construct words in any language, like whether oyogera Luganda n'ogamba nti njagala kuwandiika ebbaluwa, I want to write a letter to my friend. Of course, the first step kuba kumanya ennukuta, the letters that you can use to express the words. So you have essentially when you want to communicate, like I was saying, you find that conceptually you start with a thought. Oyagala kuwandiika ebbaluwa ogiweereze mukwano gwo. So you have a thought that you want to communicate. So you need to put that thought into words. And when you want to put a thought into words, of course, words are a sequence of symbols. For example, in most of our typical languages, we use the Latin alphabet, the letters A to Z. So you know that I want to say I love you. So I is a letter, then you have to put space, then you write the word love, L-O-V-E, like that. So even for computers, nga ogezaako okulagirira ebyuma bino what to do. Nkwenda oyimbe amaizi gano ogaye hano ogatwale kuli, oba nkwenda oseesere ebimuli ebyo buli musana bugukwaka. So you want the machine to listen to you. Like now we have this robot that we built at Mutual is called Vosa. You can talk to it and give it a voice command. Please, what is the time? You'll want to express your thoughts or your commands or your wishes to a computer using some instructions. So in the T language, our commands are built using letters. Our keywords, what in other languages are called primitives or primitive instructions, are just letters. The letter A means anagrammatize, get a word or a string and jumble the contents. The letter B is basify, take as an expression and reduce it to only its orthogonal or unique elements, especially preserving the order of occurrence. The letter C is clear, take what is in memory in the computer, what has been stored, and empty those registers or memory cells. The letter D is delete, take some pattern and delete something in a given or target expression, etc. Up to Z, which is zap, which says bring some powers from out there and let's use them to do something. So when you combine these letters, just like in natural languages, you combine letters to make a word. Also in the T language, you combine these letters to create a kind of program. So every word, like the word, if you took a word like book, which is B-O-O-K, if you turn that into a program, that would be basify, order, then keep. So that program, for example, will take an input, it will reduce it to its unique elements, then it will order them, meaning it will resort them in maybe ascending order, and then keep. It may decide that only keep this particular element. So that program will reduce a large string to a smaller one and will sort it in a certain way and eliminate something. So you see that the word book can be a very useful program in T. So that is part of the power of this language. And few languages out there can have many things using a small set of instructions. You find that a T program, which is very advanced, like Z Hacker Assistant, is just 120 lines of code, and those lines could even be further reduced. The kind of number of commands you use to create such a complex program are even smaller, because in T, a simple primitive like U, which is uniquify, it does some statistical analysis. If you give it 2 paragraphs, maybe about 50 words, it can reduce it to just a string telling us what are the most frequent letters in that message. So just in one character like this, you're able to do that kind of thing. So it is a general purpose programming language with a text processing oriented paradigm. So many people who are used to functional programming, who are used to imperative programming, who are used to what? List programming and etc. Yes, we'll find something new to learn about T. Also, T has no complicated data types. Everything in this language is a string, and occasionally maybe we come across regular expressions. So, these some of the important publications. This is the TARS. Yes, and it is one of those books or important manuscripts that you can go to understand how each primitive in the T programming language works. For example, salt allows us to inject space randomly in an expression, and this can help us to structure or restructure an expression in new ways. For example, we use that in the personal assistants that we have designed recently, and many other things. So look at this work and download those books and papers, and please get to look at some of that stuff. Yeah. Project of the transforming executable alphabet on GitHub. You're going to find that among things that we have included is, first of all, a little bit about the background of the language. There are some examples that can show you how to write simple programs like Hello World, and then how to progress from Hello World to more advanced examples. Right now, the most important example on that page, or the most exciting for those who are a bit already familiar with programming and computers, is called the Z Hacker Assistant. So we have built a kind of quasi artificial general intelligence, and when you look at this program and what it could do for humans right now, you'll be amazed, because it allows you to interact with anyone, anything from your computer, and this to happen even without needing the internet or a data connection. Because now today, when you want to chat with someone and they're not physically with you, you have to have some data connection. Either you call them, you send a text message, or you go on a social media app. You need network between these parties. Whereas with this new kind of technology chatbot we are building, essentially, you may say the link between you and that other person is psychological, or is telepathic, or it is an abstract link. It doesn't have to be physical. Yet, when you look at the results you get from this, a lot of science since the early centuries, but I think if you look back at the growth of modern science, like 20th century science, you find that even in fields like medicine, what has been called we have the placebo effect, for example, whereby someone could have an illness, and when the doctors or the scientists don't know exactly how to go about treating this illness, sometimes you can get what is called a placeholder drug, a placebo, and when it's given to the patient, and the patient believes that this drug will actually heal me, and the doctor packages it in a good way, you find that actually the person gets healed. Science doesn't yet exactly know how the mechanism works, but it is believed that there is something in a human that transcends just the biology. So even in this case of technology, we believe there is something more than just the algorithms and the machine interaction of a human. A human can talk with another human who is not there in that space and time. A human can talk with an entity that is fictional, and they can exchange ideas. A human could be inspired by a non-physical being or a non-human being. Some of these things have been in science fiction, but now we are looking at them practically in reality. So part of the philosophy ideas behind this are in the paper that Joseph has shared. It is also linked on the T GitHub page, and it's much encouraged to look at these things. So looking forward, of course, we want to improve this technology so that it can give us more realistic solutions to everyday problems, but also we don't want to limit ourselves by what is currently being done by everyone, because already when you want to chat with a friend in a normal way, you can use social media. When you want to chat with a robot just to pass time or to get some also chat GPT. But few people or a few researchers out there are looking at cases where you want to communicate with a non-human, you want to communicate with a fictional character, things of that sort. So these are the things that we're kind of exploring. And of course, as they say, when NASA or the European Space Agency is researching about life on Mars or life on Jupiter, some people can criticize and say, but why are we concerned about things on Jupiter or on Mars? But you find that by investigating or investing in such complicated or advanced science, maybe touching on matters in other words, the results can bring back beneficial effects or beneficial side results that can actually benefit us in this present moment. So the same is happening here. So that's it. We shall look at what the highlights are and hopefully like problem solving. Learn about these things, and I see that this is the future of programming, the future of software engineering, and that our children, our engineers, but also our educators need to start learning and putting into application these works.